In this video, you'll learn how to train an agent to play the game Atari Breakout with PerceptiLabs. You will develop and train a model that can play a game by using reinforcement learning. To help with this project, you'll use OpenAI's game environment Gym included with PerceptiLabs. We will be using the well-known technique DQN or Deep Q Network. By the end of this tutorial, you will have a fully trained model that can be exported as a TensorFlow model. Let's start by creating the project. Navigate to Recent Projects on the home screen and click Add New Project. Now, click Data in the Operations menu. This displays 3 data operations. To learn more about PerceptiLabs UI, watch the tutorial PerceptiLabs User Experience. Drag and drop the second one, which is the environment component, onto the workspace area. Double-click on the component. Here you have a drop-down where you can choose which environment, or in this case, which game, the model should learn how to play. Here you can also see a sample of data from the environment, the game Atari Breakout. The action space is the number of actions the agent can take. In this case, it's 4, which means go left, go right, stand still, and shoot. History length explains how many frames in a sequence we want to stack. The frames will be stacked in the last dimension. In this case it's 10, which means the output dimension will be 210 times 160 times 30. You can also swap over to code view and use a custom environment. Okay, let's apply and confirm the settings. Next, we navigate to Processing menu, choosing the grayscale component. This will transform each sample from RGB to grayscale. Remember to always double-click on the component, otherwise the settings will not be applied. Double-click on the grayscale. The code view window will open. This component doesn't have a settings, but it's modifiable via the code editor. Click Apply and confirm. Then, from the Deep Learning menu, pick Convolution component, since we are working with image data. Double-click the component. To learn how to edit the settings of this component, watch the tutorial Getting Started with PerceptiLabs. Click Apply and confirm. After that, navigate back to Deep Learning menu, but this time choose Fully Connected Component. Double-click the component. Set the amount of neurons to the same number as the action space we saw in the environment component, because this component is where the model estimates the best probable action. In this case, it's 4. Click Apply and confirm. Go to Training menu, choose Reinforcement Learning component. Connect the output of the model to the training component. Double-click the component. Click Apply and confirm. Now, click Run and begin training the model. To better understand the statistic dashboard, watch our tutorial PerceptiLabs User Experience. However, this time the statistic dashboard will look a little bit different because we are using reinforcement learning rather than supervised learning. For example, here we can see how the reward increases over time. Then, how many steps we take before we end the session in the game. This also we want to increase over time. We can also see the distribution of what action to take. You might also find it interesting to see what is going on in the convolutional component. Then it will look like this. For the model to learn the game, it will take a longer time in training, so we will leave it up to you to take it from here. To learn how to test and evaluate the trained model, as well as export it, refer to the PerceptiLabs User Experience tutorial. Thank you for watching. If you have any questions, feel free to reach out to us via our Slack community.